Good morning, children. Let us move to the next topic of the chapter, wave optics. I hope all of you studied that last class topic, that is how the interference pattern is formed. Okay, what is interference? How the interference pattern is forming in Young's double slit experiment. We were discussing about Young's double slit experiment. Okay, that is two slits are there. From the two slits, the light waves are coming and they are superposing, where the crest and trough are superposing. That region will be bright, where one crest and one trough is superposing. That region will be dark. That is because of the variation in the intensity. Okay. Now we are moving to the mathematical explanation for this Young's double slit experiment. So that practically we are getting the alternate dark and bright band on the screen while doing this Young's double slit experiment. Now we are going to explain the mathematical verification. So how there is a variation in the intensity and what are the factors affecting all these things we are going to discuss now. Okay. So just to recollect that our parent source, and from the source through the two slits S1 and S2 the light waves are coming, crest and troughs are propagating like this and they are superposing, and on the screen here we are getting the bright region, then next to that there is a dark, here also we are getting dark, and here bright, like that it is continuing, isn't it? And how we are getting bright region here? Yes, the waves, crest of the waves and troughs of the waves are superposing. So the intensity increases. And here crest of a wave and trough of the another wave is superposing. So here it will be dark. Okay. So we can take, let y1 be the displacement of the wave coming from the slit S1. Okay. Y1 is the displacement of the wave coming from the slit S1. So y1 in the wave representation we can write y1 is equal to a1 sine omega t. a1 sine omega t, where a1 is its amplitude, omega is angular frequency and time is t is the time. And y2 is the wave coming from S2 and it is equal to a2 sine omega t plus phi. a2 sine omega t plus phi. Okay, that is a wave representation. y1 is equal to a1 sine omega t and y2 is equal to a2 sine omega t plus phi, where phi is the phase difference. We know that it is the phase difference. And these are S1 and S2 are coherent sources. We know that S1 and S2 are coherent sources. So coherent sources, what is the condition? It may have a 0 or constant phase difference. If it is 0, phi is equal to 0. Constant phase difference means maybe pi by 2 or pi or 270, anything. Okay, so we are, in general expression, we are writing it as phi. It may be 0 or any other value. Okay, so y1 and y2. And what is happening? They are superposing, isn't it? On the path, they are superposing. And according to the principle of superposition, we know that the resultant displacement y is equal to y1 plus y2. Y equal to y1 plus y2. We can substitute a1 sine omega t plus a2 sine omega t plus phi. Okay, then expand this a1 sine omega t plus, what is this? Sine a plus b. What is sine a plus b? Sine a cos b plus cos a sine b. So it is a2 sine omega t cos phi plus a2 cos omega t sine phi. Okay, so expanding this. In what is said, taking the term omega t. So here sin omega t is there, here also sin omega t is there. So we can write it as a1 plus a2 cos phi within the bracket sin omega t is common plus I am just rewriting it as A2 sin phi cos omega t. Okay, that is sin omega t cos omega. Just interchange and wrote. So A1 plus A2 cos phi sin omega t plus A2 sin phi cos omega t. So just mathematical steps. And here we are doing a substitution. Here we are doing a substitution, and that substitution is instead of A1 plus A2 cos phi, instead of A1 plus A2 cos phi, I am writing it as A cos theta. So what is this A and what is this theta? We will explain later. And instead of A2 sin phi, I am writing A sin theta. Okay, just replacing this by capital A cos theta and this is capital A sin theta. So what will be the new wave? Y is equal to A cos theta sin omega t plus A sin theta cos omega t. Okay, then A is common here, and this we can consider sin omega t cos theta plus cos omega t sin theta. That is again in the form of sin A plus B. That is sin omega t plus theta. Sin A plus B. Sin A cos B plus cos A sin B. Okay. So this proves that after superposing also we are getting a wave, and which wave? It is also a sine wave. Okay. So that is the proof here. So superposition, mathematically this we just said superposing of the wave, that is energy is getting added or what is that, subtracted. So and what is the resultant? Resultant is also a sine wave. And what is the amplitude? A sine wave of new amplitude A. Okay, new amplitude A and a new phase difference theta, and a new phase difference theta from two waves. Y1 is equal to A1 sin omega t, that is amplitude A1, and Y2 with amplitude A2 with the phase difference Y are superposing. There is a resultant sine wave, that is Y, with amplitude A and a phase difference theta. So it is not necessary that the resultant wave is also the same phase difference. So it may be of another phase difference theta, and it is having another amplitude, that is A, where A is the amplitude of the resultant wave. That's A is taken here. Okay, and theta. So this shows that. So after that you have to write, this is the question for you, and after these steps you have to write the resultant wave is a resultant wave is also a sine wave of amplitude capital A. Okay, the resultant wave is also a sine wave of amplitude A. So resultant wave we are getting, that is a sine wave. Now we have to get the expression for this A, and we have to define what is this theta. Okay, so you write down the question and write up to this. So our question is expression for the intensity, and derive an expression for the intensity. Okay, so here we reached up to the amplitude. From that you have to connect it to the intensity. So you write up to this. Okay, so we got the final equation, that's the resultant wave. Y is equal to A sin omega t plus theta. Look at this equation. We can name it as equation 1 and equation 2. And I am doing that, I am squaring equation 1 and it is added with the square of equation 2. Squaring and adding these two equation 1 and 2. So what is it? Squaring and adding this equation 1 and 2 gives what I said. We can write this RHS first, that is a square cos square theta plus a square sin square theta is equal to, I am writing it here, then only I can complete it here. So what is it? A1 plus A2 cos phi whole square plus A2 sin phi whole square. Okay. So what is this? A plus B the whole square. So what is it? A1 square plus 2A1 A2 cos phi plus A2 square cos square phi plus A2 square sin square phi. Okay. So A1 square plus 2A1 A2 cos phi plus A2 square cos square phi plus A2 square sin square phi. Then again you can see that last two terms, that is A2 square is common. So what is it? A1 square plus 2A1 A2 cos phi plus A2 square cos square phi plus sin square phi. What is cos square phi plus sin square phi? 1 plus square theta, cos square theta plus sin square theta is 1. So it is A1 square plus A2 square plus 2A1 A2 cos phi. 2A1 A2 cos phi. And look at here also A2 square, A square is common. So cos square theta plus sin square theta is again 1. So it is A square. So what is it? I told you A is the amplitude of the resultant wave, that is A square is equal to A1 square plus A2 square plus 2A1 A2 cos phi. 2A1 A2 cos phi. That theta term is not there now. Isn't it? Theta we have taken and it is the phase angle between the resultant wave and the parent waves. But now in the equation the amplitude that is not coming. So that is the amplitude of the resultant wave. How is it changing, or how it is depending upon A1 and A2, or A1 and A2 are the amplitude of the individual waves. So it is A1 square plus A2 square plus 2A1 A2 cos phi. That is, it depends upon only the phase angle between, or the phase difference between the individual waves. That is from the source S1 and S2, the waves coming, and what is the phase difference between them. Accordingly, what is it? The amplitude of the resultant wave changes, isn't it? A1 and A2 are constant, that is the amplitude of the wave, it is not changing. So there may be change in cos phi. So accordingly, the amplitude of the resultant wave changes. Okay. So next you write down this as equation 1 and equation 2. Squaring and adding equation 1 and 2. We will get this, which is the amplitude of the resultant wave. Okay, A square is equal to A1 square plus A2 square plus 2A1 A2 cos phi is the amplitude of the resultant wave. Okay, so continuously you can write. No need of writing this from this. So amplitude. So this equation you have to study. So we got the amplitude. A square is equal to A1 square plus A2 square plus 2A1 A2 cos phi, or A equal to square root of A1 square plus A2 square plus 2A1 A2 cos phi. A is equal to root of A1 square plus A2 square plus 2A1 A2 cos phi. Okay. Then, now you got the amplitude. So, how we will connect it with the intensity? What is the relation between intensity and amplitude? Yes. Intensity is equal to, or it is proportional to square of the amplitude. Intensity is proportional to I, proportional to A square. where I is the intensity and A is the amplitude. Okay, another relation, I proportional to K square. So how can we write the intensity of the resultant wave using this relation? Yes, we can write it as, take I is the intensity of the resultant wave, I1 is the intensity of the wave from the slit S1 and I2 is the intensity of the wave from the slit S2. We can write I equal to. So here what is it? I proportional to A square, I1 proportional to A1 square and I2 proportional to A2 square. So proportionality we have to change. So it is equal, we are taking a constant Ka square, Ka1 square and Ka2 square. Okay, so we can write, what is it? I is proportional to A square. So instead of A square we can write K, instead of A square we can write I by K is equal to I1 by K plus I2 by K plus 2 root I1 by K root I2 by K cos phi. Okay, so here it's only A1. So A1 means, what is it? Square root of I1 by K. A2 is square root of I2 by K. So I by K is equal to, what is it? I1 by K plus I2 by K plus 2 root I1 by K root I2 by K cos phi. So here root K into root K, that is K. So all the K get cancelled. So I is equal to I1 plus I2 plus 2 root I1 I2 cos phi. So what is it? This is the intensity of the wave. Intensity of the resultant wave. That is, from the two slits, waves are coming. Just imagine, from the two slits, the waves are coming. They are superposing and they are falling on the screen. Okay, while falling on the screen, what will be the intensity? Intensity will be I1 plus I2 plus 2 root I1 I2 cos phi. Okay, and amplitude is A square is equal to A1 square plus A2 square plus 2A1 A2 cos phi. So how the intensity varies? We know that intensity is varying, isn't it? One place it is bright, that is the center portion, it is bright, then it is bright, then it is dark, and here it is dark, next it is bright. So alternatively we are getting dark and bright band. That is, the intensity is varying. So how the intensity varies? See, it is I1 plus I2, it is not changing. But here 2 root I1 I2 again not changing. So it is varying according to the value of cos phi. And what is cos phi? What is phi? Phi is the phase difference between the wave. Here the waves are out of phase. Here the waves are in phase. Last year you studied like in phase and out of phase. So what is the phase difference between the wave and alternating current also we discussed, isn't it? So if both the crests are passing the same time, it is in phase. And it is out of, now it is there is a phase difference of 90 degrees, isn't it? Here the crest comes, maximum amplitude comes, here the amplitude is minimum. So there is a phase difference. So according to the phase difference, we know that there is a difference in superposition, isn't it? Here it undergoes constructive superposition and here it undergoes destructive superposition. So as the superposition changes, constructive means what happened? The resultant will be more. Destructive means the resultant will be less. What? Resultant intensity. So if it is according to the value of phi, according to the value of phi, it may be in phase or out of phase. Or accordingly it undergoes constructive or destructive superposition. Okay, so this term, so the intensity is depending upon the last term, that is 2 root I1 I2 cos phi. It is known as interference term. interference factor or interference term, because these terms decide whether it is constructive superposition or destructive superposition, or we can say thus undergoes constructive interference or destructive interference. So this term is known as the interference term. So we can derive the general condition when it undergoes this constructive interference and destructive interference according to the value of cos phi. It's a cos value, isn't it? So we know what is the maximum and minimum value of cos. So accordingly we can say with what will be the intensity, if the intensity will be maximum or if the intensity will be minimum. Maximum intensity means what will be the condition? It is undergoing the construction, isn't it? And minimum intensity means it will undergoing destruction. So the constructive interference happen or the destructive interference happen according to the value of cos phi. So next we have to find out the condition for the constructive and destructive interference. Okay, so this is the expression for the intensity. So expression for intensity at any point on the observation screen in XW slit experiment. So at any point this will be the intensity, and how the intensity varies? Intensity varies according to the cos phi term or phi, that is the phase difference between the waves, okay, from the two slits. So next we have to see the condition for constructive interference. We have the equation for the intensity I equal to I1 plus I2 plus 2 root I1 I2 cos phi. So constructive interference means the intensity will be more, maximum intensity. So what will be the value of cos phi there? That is I1 plus I2 plus, this should be also added, isn't it? So what will be the value of cos phi, maximum value of cos phi? The value of cos phi is maximum, the intensity also maximum. So the maximum value of cos phi is equal to 1. Minimum value is minus 1. So cos phi. So what are the conditions or what are the values of phi to get cos phi is equal to 1? Yes, phi is equal to 0. So if cos phi is equal to 0, cos 0 is equal to 1. Cos 0 is 1. Then 2 pi, isn't it? 180. Cos 180 is again 1. Cos 4 pi is again 1. So etc. That is the even multiple of pi, isn't it? Even multiple of pi. That is phi. What is phi? Phi is the phase difference. Phase difference between the waves. Phase difference between the waves. So if there is no phase difference, or if there is a phase difference of 180, or if there is a phase difference of 4 pi, those waves undergo or superpose constructively. And what will be the intensity? The intensity will be maximum. Okay, so that interference is known as constructive interference. How is it? See, this is the first wave and this is the wave from the second slit, isn't it? Is there any phase difference now? No, they are in phase, isn't it? So they will add and we will get a new wave of amplitude A and intensity I. If this is A1 amplitude, A2 amplitude, I1 intensity and I2 intensity. So here the intensity increases. Okay, here the phase difference is 0 or phase difference is 180. Phase difference 180 means what? This is the first wave, it's propagating, then 180 degree out of phase, next wave is coming, isn't it? So it is a continuous one. So how they will add? They will also add constructively. They will superpose constructively and we will get a resultant wave of maximum intensity. So how can we say if the phase difference phi equal to 0, 2 pi, 4 pi, etc. What is it? Intensity will be maximum. Intensity will be maximum. That is the condition for constructive interference in the terms of phase difference. Not only in terms of phase difference, we can say that relation in terms of path difference also. That is path difference P between the waves. So here the difference in angle, and path difference means it is the difference in length. So how we said this is the first wave and this is the second wave. Is there any path difference? No, there is no path difference. The distance traveled, it is same, that is lambda. Both are lambda. Path difference means it is in terms of the wavelength. So this is the first wave and this is the second wave. So what is the distance between the initial point of two waves? That is known as the path difference. So here this is the starting point or end point, or this is the starting point and this is the starting point of the wave, isn't it? So it started from here and it reached here. So what is the difference between these 2 points? The difference between these 2 points is equal to lambda, isn't it? But that is equal to the length of this wave, that is lambda. And if the phase difference is 4 pi. 4 pi means here the second wave and this is our first wave. So now the phase difference is 4 pi, and what will be the path difference? Path difference is the distance between this. So here there is one lambda, here there is another lambda. Okay, so P is equal to the path difference. So what can we write? We can write it as, if the path difference P is equal to 0 or lambda or 2 lambda, or 3 lambda. In such cases also, what is said, they undergo constructive superposition and the intensity will be maximum. Okay, intensity will be maximum. Intensity maximum means what will be the brightness of that point? Yes, it will be more bright. That region will be a bright region, isn't it? So if phase difference is equal to this, and if path difference is equal to, or we can write it as n lambda, where n is equal to 0, 1, 2, 3, etc., will undergo what? Constructive interference or constructive superposition. And what will be the intensity? Intensity will be maximum. So constructive interference means maximum intensity. So what are the condition? What is the condition between the two waves to undergo this constructive superposition or constructive interference? That is, it should maintain either a phase difference of 0, 2 pi or 4 pi, that is the even multiple of pi, or path difference may be the integral multiple of lambda. Okay, so that is the condition for constructive interference. So in Young's double slit experiment, from the two slits waves are coming, and if they are maintaining a phase difference of even multiple of pi or integral multiple of lambda, they undergoes constructive interference or they superpose constructively, and that region where these waves are falling, that region will have maximum intensity and it will be a bright region. Okay, clear? So that is the condition for the constructive interference. So write down condition for the constructive interference, the phase difference and path difference in two cases. Path difference P is equal to n lambda. So this is a 1 mark question. Okay, condition for constructive interference, P is equal to n lambda, 2n lambda or lambda by n. Options will be there. So what is the answer? Should be n lambda. Next, the condition for destructive interference. What will be the condition for destructive interference? Yes, the intensity I is equal to I1 plus I2 plus 2 root I1 I2 cos phi. So what will be the intensity? Destructive means it will be minimum. So we have to consider the minimum value of cos phi. What is the minimum value of cos phi? Minimum value of cos phi is equal to minus 1. Isn't it? So what is the value of phi? Yes, it is 180, 3 pi, 5 pi, etc. Like cos 180 is minus 1. So if phi is equal to pi, 3 pi, 5 pi, etc., what will be the path difference? So 180 means what is the path difference? Isn't it? So here phase difference is 180. Phase difference is 180 and the path difference is the distance between these 2 points. How much it is? It is lambda by 2. Isn't it? Half of the way. And if it is 3 pi, it will be 3 lambda by 2. It will be 5 pi, it will be 5 lambda by 2. Isn't it? Then next wave is here means what is it? Lambda by 2, this lambda by 2 and next lambda by 2. See, it will be here. Isn't it? So lambda by 2 and next lambda by 2. So it will be 3 lambda by 2 or 5 lambda by 2. So the path difference we can write it as it will be lambda by 2, 3 lambda by 2, 5 lambda by 2, etc. Or we can generalize it. It is 2n plus 1 lambda by 2 where n equal to 1, 2, 3, etc. Isn't it? N is equal to 1 means, sorry, we can start from 0. N is equal to 0, 1, 2, 3, etc. See, n is equal to 0 means what? 2 into 0, 0. So it is lambda by 2. Then n is equal to 1. 2 into 1, 2 plus 1, 3 lambda by 2. Then 2 into 2, 4 plus 1, 5 lambda by 2. Then 3 amber, it comes 7 lambda by 2. Okay. So what is it? If the phase difference between the two waves coming from the slit S1 and S2 having a phase difference of pi, 3 pi, 5 pi, etc. that is the odd multiple of pi, and the path difference is equal to 2n plus 1 lambda by 2 where n is equal to 0, 1, 2, 3, etc. Those waves undergoes how destructively, isn't it? This is the wave and this is the next wave. What is the phase difference? It is 180, isn't it? This is the phase difference. Here 90 and plus 90, it is 180. So phase difference is 180 and path difference is lambda by 2. So which all are superposing here? Yes, crest of a wave and trough of another wave. So what will be the intensity? There is destruction. So intensity reduced, and what is it? That region will be a dark region. Okay, and that interference is known as destructive interference. Okay, so what is the condition for destructive interference? If phase difference is pi, 3 pi, 5 pi, etc. or path difference is equal to 2n plus 1 lambda by 2, then the result intensity of the resultant wave will be, what is it, minimum, or it undergoes destructive interference or destructive superposition and destructive interference. Okay, so that is the condition for constructive and destructive interference. So we proved that the resultant wave is a sine wave, and we got the expression for the amplitude, we got the expression for intensity, and from that we have seen that a term called interference term or interference factor, and based on the variation of that interference factor we could explain the constructive interference and destructive interference. Okay, so this is the mathematical verification of what Young's double slit experiment. Next we have to see where on the screen, where will you get the bright region, where will you get the dark region, and what is the distance between each dark and bright region in Young's double slit experiment. Okay, so next we have to discuss about the fringe width in Young's double slit experiment and how can the wavelength of monochromatic light be found by the experiment. So before discussing about the fringe width, I will tell you what is fringe width. You have to see, you have to know where will be the dark, or which region will be the intensity maximum, which region will be the intensity minimum, so that mathematically we can prove. So here this from the source, what is it, the light is coming to a small two slits, that is we can call it as S1 and S2, and it is separated by a distance d. Okay, and remember that d should be too small. Okay, it should be in the millimeter range only. If you are keeping it in the meter range or the kilometer range, we can't observe that interference won't happen. That is, two sources of light, it should be very close. Okay, that gives a better interference pattern. So S1 and S2 separated by a distance d, and this is our screen, and I told you it is about 1 meter, that is taken as capital D. Okay, and on the screen you are just taking a point. I am taking a point P here. Point P here. Okay, and this I am taking as the center. So from the center I am marking it as O. From O, this P is at a distance x. From center O, it is at a distance x. That is center. I have taken that center of these two slits. Okay, distance between the two slits, and it is at a distance. This point P is at a distance x from the O. Okay, so you can consider the downward direction also. You can consider the point P here. So same thing will get. Okay, so at P, and now we have to say, we have to find out what will be the point P. What is the intensity at P? Is it dark or is it bright? Maximum intensity or a minimum intensity? Or the waves from here, the waves are propagating, and the resultant wave falling here, whether it is undergoing constructive interference or destructive interference, or they are superposing constructively or destructively. Okay, so what is the condition for that? That is what we are going to derive. Okay, so from S1 to P, this is the distance travelled by the wave. So S1P is the distance travelled by the wavefront from S1 to P. Isn't it? And same time from S2 also the wavefront is propagating, and it is moving towards P and reaches P. So what is the distance travelled by those wavelets from S2 to reach P? That is S2P. Isn't it? So it is very clear that from S1P the wavelets are reaching at S1, the wavelets are reaching at P, and S2 also the wavelets are reaching at P. So there is a path difference between those two waves, isn't it? I am drawing a normal from S1 to this, that is at the point N. So here S1, P and NP are same, isn't it? So two lines are there, and if you are drawing the normal, what is it? These two distances are same. So same way, what is it? Here S1P and NP are same, isn't it? So there is a path difference, that is S2N. There is a path difference S2N between those wavelets propagating from S1 and S2 towards P. Then if you can find out what is that S2N. Now we have the condition for constructive and destructive interference, isn't it? If the path difference is n lambda, those waves will undergo what superposition? Constructive superposition. And if it is 2n plus 1 lambda by 2, those waves undergo destructive superposition. So that condition we know now. So if you can find out what is this S2N, and if you can compare with that condition, you can say whether the point P will be a dark or bright. So we have to find out what is S2N. S2N. So I am doing some construction here, that is from S1. I am just joining to the screen. Okay, and I am taking this point as A, and this point as B. So this is D and this is at the center. We can take this as D by 2 and this is also D by 2. Okay, and you have to remember this D is too small. Okay, and this P is also should be very close to that. We can't observe the interference pattern at a very far distance. Okay, the slits may be kept very close and the screen also near or a particular distance, and around that only we can observe the interference pattern. So this is the construction. Look at the diagram. From the diagram you can see two right angle triangles. So the first triangle I am considering, that is triangle S1PA, S1PA, right angle triangle. So I can write S1P square is equal to, what is it, S1A square plus PA square. S1A square plus PA square. Okay, that is hypotenuse square is equal to base square plus height square. And next triangle is triangle S2PB. S2PB. In S2PB, I can write S2P square is equal to, what is it, S2B square plus PB square. PB square. Take this as equation 1 and this as equation 2. And equation 2 minus equation 1. Equation 2 minus equation 1, what is it? S2P square minus S1P square is equal to, what is it? S2B square plus PB square minus S1A square plus PA square. Okay, and this is in the form of A square minus B square. What is A square minus B square? It is A plus B into A minus B. S2P minus S1P into S2P plus S1P is equal to S2B square plus PB square minus S1A square plus PA square. Okay. And what is this S2P minus S1P? S2P minus S1P. Isn't it? So that difference is S2N. Isn't it? That is S2N. We have S2P minus S1P is equal to S2N, which is equal to P. What is that P? It is the path difference. Okay, path difference between the two wavelets from S1 and S2. So from this, can you find out this S2P minus S1P? Yes. So we can write therefore what is it? P equal to, or write it as S2P minus S1P is equal to S2B square plus PB square minus S1A square plus PA square whole divided by S2P plus S1P. Okay. So you write up to this is the question and draw the diagram. While writing the answer, you have to draw the diagram neatly and label everything. Okay, what are the things we label? Everything should be there in the diagram neatly. So after drawing the diagram neatly, no need of writing the explanation for that. Then you can start from here, from triangle, this equation 1, 2 and this. Okay. So after that we will continue. So you complete this and we will go for the next one. So I can write it here. So I am rubbing it off. So we have, therefore, what is it? P, like path difference, P equal to S2B square plus PB square minus S1A square plus PA square whole divided by S2P plus S1P. The next is only the substitution for this S2B, PB and all. Okay, so we can substitute here. What is that substitution? What is S2B? S2B is D, isn't it? So D square plus what is PB? PB is the distance from here to here. That is from O it is X and we have to add D by 2 also. Okay. So it is X plus D by 2 the whole square minus, I am opening the bracket here itself. What is S1A? S D square plus PA square. What is PA square? Yes, PO is X and PA is PO minus AO. That is X minus D by 2 the whole square divided by, this we will substitute at last, S2P plus S1. Okay. Then what is it? Here D square get cancelled. Isn't it? So opening the bracket, so here comes negative. So D square cancel. Then this is, we can expand A square plus 2AB plus B square minus A square minus 2AB plus B square divided by S2B plus S1. This is A plus B the whole square, A minus B the whole square. Your negative sign is there, so that accordingly we have to substitute the sign. Okay. So this x square cancel, D square by 4 cancel, 2 cancel. So what is remaining? It is 2xd divided by S2P plus S1P. So here what is P? S2P minus S1P, isn't it? Here we are assuming that is the point P. I told you if it is too far, P is too far, we won't get the interference pattern. So what we will consider? We will consider that P is close to O. That is P is close to O means what is it? S1P and S2P are nearly equal, approximately equal, and that it becomes equal to D here. Okay, but the condition is we can't take S2P minus S1P, that is here D minus D is equal to 0. We won't consider, that's a difference we will consider. But while adding, what is it? It will be a number that we won't consider. Okay, that addition. So in addition, we will consider D plus D equal to 2D. But here subtraction, what is the difference that we need? So we will consider that. Okay, so that is the assumption we are doing here. That is, it is P is too close to O. We can write it as D plus D. Okay, P is, what is the condition? P is too close to O. S1P equal to S2P equal to D. Okay, so that is the condition assumption we are following here. So what is it? It is equal to X D by D. That is the path difference P is equal to X D by D. That is the point P is at a distance of X D by D. Not P, what is it? The path difference between the waves from S1 and S2 is there is a path difference of X D by D. That is the path difference. It depends upon X. What is X? X is the distance between the center of the screen and the point which we are considering. And D is the distance between the slits, and capital D is the distance between the slit and the screen. Okay, D is the distance between the slit and the screen. So here from here itself we can see how the path difference varies. As X increases, the path difference increases. Distance increases, between the slit increases, path difference increases. Okay, and D is decreases, path difference increases. D and P are inversely proportional. Okay, if it is come close, what is it? The path difference increases. If it is going to far, path difference decreases. Okay, so based on this equation, there will be 1 mark question. Okay, that is what happened to the path difference, or x doubles, what happened to the path difference, or D reduced to half, what happened to the path difference, and this distance between the slit increases, what happened to the path difference. Okay, so that is the expression for the path difference between the two ways from the slits S1 and S2. Now we have to equate it with the general condition which we are having. That is the condition for the constructive and destructive interference. Isn't it? So next we can see what is the position of bright fringes. That is from the center, which all points we will get the bright fringes. Okay, that is on the screen. Where are the points we are getting the bright fringes, means where the light waves after constructive interference falls. Okay, that region will be the bright, and this is known as fringes. That area where the dark region or bright region, we are calling it as the fringe. Okay, or band. We can call it as band or fringe. Okay, that is a small region. Fringes or bands, bright bands or dark bands. Okay, this we are representing as bright, and shading we are representing it as dark. Okay, it's the dark and this is the bright. Fringe or band, dark band, dark fringe, bright band, bright fringe. Okay, fringes. So in general we are representing that fringes in Young's double slit experiment, interference pattern as the fringes. Okay, so position for bright fringe means they are undergoing constructive interference, and we have the condition for the constructive interference. Like the path difference between the wave, if it is equal to n lambda, path difference between the waves P is equal to n lambda, they undergoes constructive interference. Okay, so what is it? We have for constructive interference. Constructive interference, what is it? P is equal to n lambda, and this is the general expression. So we can equate it, like both are path difference. So if x d by d is equal to n lambda, that is here the path difference is equal to x, that is n lambda. What is that? Those waves undergo constructive superposition, or they superpose constructively, and this point P will be what? Bright. So it constructively, and here the light falls, so it will be bright. So x d by d is equal to n lambda, or x is equal to n lambda d by d. Isn't it? X is equal to n lambda d by d. That is, if the distance between the point from center, that is x we are taking. Isn't it? If P is at a distance x, and what is that x? X is equal to n lambda d by d. We can calculate what is this lambda d by d. So lambda is the wavelength of the light coming from the source, and we said that it should be a monochromatic source, isn't it? It's a coherent source, so monochromatic. So single wavelength will be there, and D we know that is the distance between the slit and the screen, and small d is the distance between the two slits it's arranged. So if we know all these things, we can find out where will we get the bright fringe, or which region, which point will be bright. And what is this? N represents the number of fringes. That is, n is equal to 1 means, where is it? N is equal to 0, 1, 2, 3, etc. it goes. So n is equal to 0 means where x is equal to 0. X is equal to 0 means where is the point? Here. This will be the point, isn't it? That is the center point. Here, center point. So here, no phase difference or path difference between the waves coming from S1 and S2 towards O. See, from here to here and from here to here, the distance traveled will be same. So no phase difference or no path difference. So at the center O, it will be bright. Okay, that is n is equal to 0. Then n is equal to 1. N is equal to 1 means x is equal to lambda d by d. So we will get a value. So maybe we can consider it is here. So that will be bright. Or here this side also we will get the same value. It will be bright. Okay. Then n is equal to 2 means for some other point we will get, say we can say it will be here. So that x changes. So as n changes, that is the number of fringes. So n is equal to 0, it is called n is equal to 0. What is it? X is equal to 0. We will call it as central bright. That is the bright fringe at the center. Okay. Central bright fringe. Then n is equal to 1. X is equal to lambda d by d. That is the first bright. First bright. Then n is equal to 2. X is equal to 2 lambda d by d. That is the second bright. That is the second bright. N is equal to 3. 3 lambda d by d. Like that we will get n number of fringes. Okay. So that position we can locate and we will get it on the screen. So where will we get the bright band? We will get the bright fringe at x is equal to n lambda d by d. So fourth bright, fifth bright. So what is it accordingly? N value changes. Fourth bright means n is equal to 4. Fifth bright means n is equal to 5. So if we know the wavelength of the light used here and all other factors we know, we can find out where we will get the bright. Okay. So next is the position of dark. So position of dark, that is destructive. So in destructive interference, what is the condition? Path reference is equal to 2n plus 1 lambda d by d. Select 2n plus 1 lambda d by d. So we can equate it. That is x d by d is equal to 2n plus 1 lambda d by d. Sorry, 2n, not lambda d by d. What is it? 2n plus 1 lambda by 2. Okay, 2n plus 1 lambda by 2. So what is x? X is equal to 2n plus 1 lambda d by 2d. X is equal to lambda d by 2d, where n is equal to 1, 2, 3, etc. N is equal to 1, 2, 3, etc. So what is it? N is equal to 1 means n is equal to 1, x is equal to 2 in 1, 2 plus 1, 3, 3 lambda d by 2d. Sorry, start from 0. N is equal to 0. What is it? This lambda d by 2d. Then n is equal to 1. X is equal to 3 lambda d by 2d. N is equal to 2. It is 5 lambda d by 2d. So this is known as the first dark. And this is the second dark. Third dark. Like that it will go. So where it will be? X is equal to lambda d by 2d. Where is that lambda d by 2d will come? Here x is equal to 0 and here it is lambda d by d. Like. So lambda d by d half. Half of lambda d by d comes here between this. Isn't it? This is 0 and here it is, say it is equal to 5, where it will be at 2.5. So this region in between that we will get the dark. Same way here also, this side also. Here it will be dark. Then next, where is next? 3 lambda d by 2d. So here it is 2 lambda d by d. So between that, isn't it? Lambda d by d and 2 lambda d by d. In between that, what is coming? 3 lambda d by 2d is coming. So here it will be dark and here also it will be dark. That is in the same side. Symmetrically it is going. So up and down it will be there. Okay. So here, so the position for dark, where are you getting the dark? At 2n plus 1 lambda by 2d. So as the n value changes, we will get the dark and bright, isn't it? So on the pattern on the screen, we will get alternate dark and bright fringes. Okay, so that is the condition for the dark fringes. What is the condition? X is, we will get the dark at x is equal to 2n plus 1 lambda d by 2d, and we will get the bright at x is equal to n lambda d by d, and n value changes. So we will get the first dark, second dark, like that. Okay, so that is, it is the alternate. See the position, from the position we can locate it is at the alternate. Here what is the distance? It is x is equal to lambda d by 2d. So please I will rewrite that. Lambda d by 2d. Okay, so this is the expression for the fringe width. And how can you find out the wavelength? See, we have x is equal to lambda d by d, isn't it? Or n lambda d by d. So from here x, if here, see here you are getting a bright one. You are using a wavelength of lambda and you are getting the p at p as bright fringe. X we can measure. So can you calculate lambda here? Yes, lambda is equal to xd divided by nd. So using this relation, we can find out the wavelength of monochromatic light by the experiment. Okay, or from this also we can find out, that is x 2xd is equal to 2xd divided by 2n plus 1d is equal to lambda. Okay, so the condition for dark, then you write, we have x is equal to this, therefore lambda is equal to xd by nd. Any equation you can use. So here it is the enlarged form of this. So central bright is at x is equal to 0. First dark is x is equal to lambda d by 2d both side. And here next second first bright is x is equal to lambda by d, x is equal to lambda by d. And next second dark is 3 lambda d by 2d. And here also 3 lambda d by 2d. Second bright is 2 lambda d by d. It will go the both side. Okay. And in some textbook you can see that the case of that is the dark, path difference is taken as 2n minus 1 lambda by 2. Okay, 2n minus 1 lambda by 2. In such cases you can take, that's what is it, you can start with the n is equal to 1. If you are taking plus, n is equal to 0. So some books it is followed like this. So doesn't matter. So you just remember that if it is minus, n is equal to, n starts from 1, 2, 3, etc. If it is plus, 2n plus 1 lambda by 2, it starts from n is equal to 0, 1, 2, 3, etc. Okay, so that is the difference. So here, 0, first central bright, first bright, both side, second bright. Okay, then these are the first dark, second dark, third dark, it will go on. Okay. We have to see what is the width of the fringe. What is the width of the fringe? So look at this bright fringe. Where is that bright fringe? That bright fringe is situated between two dark fringe at the position 3 lambda d by 2d and lambda d by 2d. Isn't it? The second dark is at 3 lambda d by 2d and first dark is at lambda d by 2d. So in between that, so what is that distance? Minus, isn't it? So what is it? It is lambda d by d. Lambda d by d. And look at this dark. Where is this dark? This dark is between two bright. So where is the position? That is between 2 lambda d by d minus lambda d by d. Like between two bright, this dark is situated. So how much it is? It is also equal to lambda d by d. It is also equal to lambda d by d. So that is known as fringe width. Fringe width. Width of the fringe. That is beta. Fringe width beta is equal to how much it is? Lambda d by d. Fringe width beta is equal to lambda d by d. So here you can see that the width of the dark and width of the bright, it is same. Okay. So what is fringe width? Fringe width is the width of a dark band or a bright band. And how will you find out? It is the difference between the, or the separation between one dark and next dark. or one bright and next bright, and beta is equal to lambda d by t. So from this we can find out, again from this we can find out lambda is equal to beta d by t. Lambda is equal to beta d by t. Okay. So fringe width, it is the width of the dark fringe or bright fringe, and it can be calculated as beta is equal to lambda d by t. So this is also a objective question using the relation, and the width of the fringe is same whether it is a dark or a bright, it is having the same fringe width. Okay, so that is about the inductance. Little more is there, so that we will discuss in the next class. So listen the video carefully. Okay, listen the video carefully, complete the notes. Any doubt you can contact me. That is all for today. Thank you.